Let's hear some chat in this room. I've never heard of that simple machine, though. One, two, three, eyes on me.
1, 2, eyes on you.
Let's hear from you folks. What do we remember? Colin O.
The parts of the lever is like the bottom part that's in the middle is called the fulcrum.
Oh my goodness, yes.
The right side is the effort and the left side is the load.
Oh, well, does the load and effort have to be on the right and left side?
No.
So what do we know about the load? Remember, think way back when we drew our arrows?
The effort is trying to lift up.
Yeah, so the effort goes down, right? The effort goes down, and the load goes up. Yes, so we said this is a fulcrum. I'm impressed. I saw a lot of people have the word fulcrum on their sheet of paper. That was the first machine we learned. Amazing. And Lily.
I remember the wheel and axle.
Yeah. What do you remember about the wheel and axle?
I remember that wheels are connected to the axle, so the axle has to keep it in place and under it and doorknob for that demonstration.
Right. Let me ask you a tricky question. In a wheel and axle simple machine, when I move the wheel, what happens to the axle? Do we remember, Colin B?
Good question. Because sometimes, in that one, it kind of moves. Like it's a trick question because in most simple machines in some simple machines they don't move, and in some they do. So it's a trick question.
But with the wheel and axle simple machine, does the axle move and the wheel moves, Delaney?
No, because the doorknob has an axle, and when you turn the wheel, that axle does not.
Ooh, are we sure? Does anyone have a different thought, Nev?
Well, it does move. I remember when we did it, I thought that it didn't move either, and then we looked at it, and it doesn't move.
Yeah, so in a wheel and axle, when we move the axle, the wheel moves, and when we move the wheel, the axle moves. This is different than a what, Lily?
The axle does move because if you move the wheel on the doorknob, it just makes it easier for us to hold on. And if it was just the axle, we'd have to use your tiny fingers and
Yeah, like when we lifted the washers, it took more force without the wheel. Yep, so the axle does move. Now this is different than what we talked about yesterday. Can we think back? When we talked about a pulley, Aiden? Oh yeah, can you come up and point to the arm on the lever? Thumbs up if we agree. Yeah, you guys really remember your levers. Okay, so in a wheel and axle simple machine, the axle moves as the wheel moves, and vice versa. How is this different than a pulley, Araya?
The axle doesn't move in a pulley.
The axle doesn't move in a pulley. Give her some jazz hands. All right, so we're going to write pulley. And I'm going to write under here axle and wheel move together. Under wheel and axle. Okay, who else? What else do we remember, Nasa? Whoa! Nasa's going way back to our first day of science when we got to play with toys. What did we remember about the toys? Were they very fun when they just sat there? No. So what did we have to do to the toys? Angelina?
We had to move them, we had to roll them, we had to bounce them, we had to do stuff like make them move. Motion.
Yeah. of force, all know, this is a very, 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 very tricky question. I hope your brains are sharp after lunch. What are the 3 things we need in order to do work? Oh, I love this. Nico.
You need to apply force to the object, you need an object, and you need the object to move.
Oh my goodness, give him some jazzy hands. I really thought I was going to get blue faces there. That was a long time ago. So we need an object. We were talking about our toys. Can't do work when there's nothing there, right? And we need, what did he say?
You need an object, you need to apply force to the object, and you need the object to move.
So number 3 on this, we need the object to move. That's when you all got really frustrated at Mrs. Matz and I. When we made you try to move the wall. We said, oh, you're not doing any work. You're not doing any work. The wall's not moving.
And I agreed.
You did agree, I remember that. So we need the object to move. And that is what we need to do work. Okay, kiddos, so now that we've done this great review, I'm going to come around, collect your cards, and we're going to learn about another special type of simple machine. Can you collect your cards in your group and I'll come around and collect them? Nico? Oh, that's okay. It's not that fun of a job. Thank you, dears. Thank you. Okay, so while I'm collecting these, if you could open up your science packets past the pulley section to the page that says inclined planes, and there should be a picture on the top of it. Whose cards?
This?
Do I have all the cards?
This?
Yep. Inclined planes.
Wow.
Now, boys and girls.
Yeah.
Boys and girls. Inclined planes are really, really special. There's something different. Oh, I need everyone's eyes on me. Yes, the page looks like this. Lots of pictures, a couple stacks of books. It's going to be fun today. So, an inclined plane is the only simple machine. Out of all the simple machines, how many are there? 5 or 6? 6? It is the only one out of 6 simple machines that doesn't move. Ooh, yeah. So, Nico told me today, just now, that he thinks a ramp is another word for a simple machine. Do we agree? Or for an inclined plane, excuse me. Yeah, is that what you said? I think a ramp is another word for an inclined plane. And he is exactly right. So I want you to talk in your groups before we get started about where you have seen ramps or inclined planes in places in your everyday life. They're a little more common than pulleys.
I do a rain paper symbol on my arms.
A what? Welcome back, kid.
We may have to do this another time. My arms are getting...
Kid, is it not prop-upable?
It's not at the angle we need.
Okay. If your arms are getting tired, I'm sure
Unless I
just
try
part of
it.
it will be fine. Oh, whoa. Okay, Mr. Collins, what are you talking about? Okay.
snake slides.
Oh yeah, I see that. I see that too. And you know what other thing you mentioned? I think on accident it's also an inclined plane. What was the last word you said? It's something you play on.
Slides.
A slide! Wouldn't you say a slide is kind of like an inclined plane? Colin? Yeah, yeah. You have a ramp at your house too?
It's true. It is true.
Okay, I'm so excited that we are really, really enthusiastic about our inclined planes. But let's tone it down a little bit so we can listen to everyone's ideas. Nisa. Yeah, the hospital. Where's our ramp at the hospital? Yeah, so something that's really, really cool about inclined planes is they can help people who can't normally go upstairs, like people in wheelchairs. They use ramps to get up things a lot. Kids? Yeah, definitely. Camp? You what? Oh yeah, and some kiddos over there were talking about like snowboarding and ski ramps too. Really shoot you up in the air. We're gonna take 2 more hands. Allie. Yeah, roofs of houses are inclined plane. And Neb.
Well, the front of my house, because my house was made where it's made for people with
Wheelchairs.
wheelchairs to get up to the house.
Yeah. Kim, can you put 4 legs on your chair on the ground, please? Okay, so let's talk about the word incline. What are we talking about here? Who knows what inclined might mean? Luca? Slanted! Yeah, and not just slanted. In this case, inclined means
Angle.
slanted up, right?
Could it also be like angle?
Yeah, sloped, slanted, it's at an angle here, right? This isn't really necessarily inclined because it's just vertical. And now let's talk, okay, so we know inclined means slanted or sloped upward. What about plane? Is this a sloping airplane that we're going to learn about today?
No.
No. No. Nico?
Probably like I kind of looked at this and I thought like a board.
Yeah, exactly. Like any sort of flat surface in this science context that we're going to be working with today is a plane. Yep.
And you're riding on a plane.
I am riding on a plane. So, boys and girls, we are going to learn about how inclined planes help us do work. Alright, so the first thing we're going to do is we are going to use our handy dandy, how many pounds did I say these weighed? 5,000 maybe, right? Super heavy, big bricks. And we're just going to simply try in your groups, 20 tons maybe, somewhere around there. We're just going to measure first how much force it takes to lift your book 4 inches off the desk. And you might have noticed each group has 2 sets of materials. We're going to do this a little differently, so just the groups will be kind of split in half so that everyone gets more of a chance to work with the materials. So 1 person for each set of materials will need a ruler. And here on number 1, oh, we're done with that.